So now let's talk about the technical adaptation. First, we're going to briefly cover the technical architecture that we designed at line 10 for the distributed system use case. Okay, so these are all the components that we designed that comply with the distributed system sort of framework, so to speak. Notice how we have our distributed storage layer that can be accessed by any program pretty much. And then, so in this case, we're going to run an ETL job, and we'll explain this in a further section, how we can essentially access files, objects, streams, or even interact with the REST API in order to interact with the distributed storage piece. So we're going to keep our chemical data set in this distributed storage layer. Now, once we have our storage here, we would ideally want to access the data, pre-process the chemical data set, and store this processed data into a faster form of storage. In this case, we're going to maintain an in-memory feature store or data structure store, so to speak, and this is going to serve as a store to the analytical layer. So let's think about training or prediction or generation. And similarly, this pre-processing phase can be accessed externally for inference tasks, or by any other program, so to speak. So yeah, that's pretty much the high-level architecture. And notice how each of our processes is ideally containerized for parallel execution on Kubernetes.